Okay, so here is a quick sample video, a quick example video in which we're going to do two problems regarding circular motion and some of the things we need to calculate when we deal with circular motion. So my first question um, is this: a small ball on the end of a 1.2 meter long string. So there's the string, right? So it's swung around and around, and it rotates 10 times every 4.2 seconds. Okay, so what is its period, its frequency, and its speed? Well, um, so what we're looking at here, people, what we're looking at is a sort of a bird's eye view of the ball going around on a string. Right, so maybe looking down from above somebody's head, and they're whipping it around and around and around in circles. And we're looking, it's going around and around, and it goes 10 times every 4.2 seconds. Now the period is how long it takes. That is to say, the number of seconds per rotation. So all I do is I take the number of seconds, right? I want my units to be seconds per rotation. So all I do is I take my seconds and I put them up top. I need seconds up top. And I take my rotations and I put them below, 10 rotations, 10 times in 4.2 seconds. So 4.2 seconds per 10 rotations. Well, 4.2 divided by 10, of course, is 0.42. And what are the units? Well, seconds per rotation, right? So that's the period right there. The number of seconds per rotation. To find period, all you do is you divide the seconds by the rotation. There's the period. That's how long it takes. Okay? So what's the period? 0.42 seconds. Now, what's the frequency? Well, the frequency is just the number of times it happens every second. So we can see that it's taking just under half a second to go around once. So in a full second, it's going to go twice, but a little bit more, right? If it takes half a second to go once, if it takes half a second to do that, well, then it does that twice in one full second. Okay? Now, that's not quite half a second, so our number is going to be just over 2. But let's see. To find frequency, it's not seconds per rotation, it's rotations per second. So we just do the opposite here. We do 10 rotations in 4.2 seconds. And I reach for a calculator because I just want to get the number right off the bat. And 10 over 4.2, 10 divided by 4.2 is 2.38. So that weight goes around 2.38 rotations every second. It takes 0.4 seconds to go once, and it goes around how many times in 1 second? Well, about 2.4 times every second. And we've got to name this unit, rotations or cycles per second. We have a name for that. We have a name for that unit, and it's called a hertz. 2.38 hertz. Right? So there's the period and there's the frequency. Okay? Now what's the speed? Well, the speed is distance divided by time. And look, there's the time right there. That's how long it takes to go around once. So we've already got that part. That's the time for one cycle. Right there. So if we can find the distance around the circle, and we divide by how long it takes, then we get the speed. Right? We have a fancy name for speed in a circle. We call it V-tan. But it's just speed, right? V-tan, or speed. Right? So I'm gonna do this. Let's see, speed. Speed is, well, distance divided by time, and what's the distance around a circle is twice the radius times pi. The distance, the circumference of a circle is 2 pi r, and the amount of time it takes we call the period. So how fast is this thing going? It's going 2 times pi times the radius of the circle. Well, in this case, the radius of the circle is 1.2 meters, because that's how long the string is. So that's a 1.2 meter radius. So 2 times pi times 1.2 divided by how long it takes, 0.42. And so this is a job for a calculator for sure. 2 pi times 1.2. My numerator is about 7.54. Divided by 0.42, my denominator, and I get about about 18 meters per second. When you do this math right here, 2 times pi times 1.2, and then you divide that by 0.42, you get 18 meters a second. So there's the interplay between period, frequency, and tangential velocity, also known as speed. One more. A person 2.1 meters from the center of a merry-go-round rotates once every 3 seconds. Sorry about the mess. Rotates once every 3 seconds. What's their period? Oh, well, this one's super easy because it says it right there. They rotate once every 3 seconds. What's their period? 3 seconds. Because that's what the period is. It's the amount of time required to rotate once. And it says it right there. Now, what's their frequency? Well, the frequency is the inverse of the period. Right? It's 1/3. 1 divided by 3. Right? And those are hertz. So that makes sense to me, right? Listen to this. If it goes around, if it takes 3 seconds to go around once, well, how many times does it go around in 1 second? Well, 1/3 of a time, right? It only goes 0.3 in 1 second, then 0.33, and then 0.33, and then 0.33. Right? It goes 1/3 of the way each second. 1/3, 2/3, 3/3, right? So after 3 of those, after 3/3, it's gone through 1 full rotation. Okay. So what's the frequency? It's 1/3. It's 1 over the period. And what's the speed? Well, the speed is v tan. It's 2 times pi times radius over how long it takes. So it's 2 times pi. And the radius is, they're 1.2 meters out. Sorry, read it backwards. They're 2.1 meters out. 2.1 meters, 2 times pi times 2.1 meters, divided by how long it takes. How long does it take? It takes 3 seconds. Right? So you bust out your calculator and you say, okay, I can do this. 2 times pi times 2.1 is whatever, divided by 3. And I get a speed, this person is going 4.4 meters per second. Okay, so I'm going to stop this recording right about now and put it up on YouTube so you guys can have it as a reference.